Good morning. Suppose we have a circuit like this and we want to using the principle of superposition, determine the current I and the mean power dissipated in the 100 ohm resistor of this circuit when both generators operate at 5000 over 2 pi hertz, and B, the current generator operates at 5000 over 2 pi hertz, whistle, the voltage generator operates at 5000 over pi hertz. Okay, first of all, when both operates at same frequency, let's do it. Because there are two generators, we have to divide this circuit into two circuits. First of all, first circuit, voltage generator operates on its own with the current generator open circuit, and the second circuit, the current generator operates on its own and the voltage generator is replaced by a short circuit. Now what we have to do first is to calculate, because we are saying that the frequency in A is omega 1 is equal to omega 2 and is equal to 5000 over 2 pi hertz. So we can calculate the reactances of this circuit. So it means that if omega 1 is equal to omega 2 is equal to 2 pi times 5000 over 2 pi, it is 5000 radian per second. So we can calculate XC1, XL1, XL2 and XC2. Here XC1 is equal to 100 ohms, XL1 is equal to 100 ohms, XL2 is 250, XC2 to 100 ohms. Now let's calculate the currents. Current means the currents I prime and I2 prime, and later we can calculate the total current that flows here is the sum of the two. Okay, let's take the first circuit and try to, here's the first circuit. This circuit doesn't exist because the current is not flowing. So here we can calculate, of course, here the reactances are equal, it means we have a resistive circuit. So it means that I prime is equal to V1 over R1 plus R4. So it means R1 plus R4 is 300, so it means it's 2 square root of 2 cosine omega 1 t. We calculated the first current, and here we can calculate second current, which is I2 prime. Here XC1 and XL1 are equal, so it means this circuit is resistive. It means we can replace it by, this circuit is reduced to a resistive circuit. We have here I2 prime, we have here the current that flows, here 8 square root of 2 sine omega 1 t, and here we have R4, so it means we can calculate the current here by the current divider method, it means that here it's R4 over R1 plus R4 times this current, which is 8 square root of 2 sine omega 1 t. So it means that I prime is equal to R4 200 over 200 plus 100. This is 300, 8 square root of 2 sine omega 1 t. And this is it's 5.333 square root of 2 sine, because frequency is same, we can write omega 1 t. And now we have to change this cosinus into sinus, 2 square root of 2 sine omega 1 t plus pi over 2. Now we have to calculate the main current, which is I is equal to, in complex form, is equal to I prime plus I2 prime. So it means that we have here, we have square root of 2 pi over 2 plus 5.333 degree. Now the main current is, we can calculate it. It's 5, because it's sum of two currents. It means we have 5.333, and here we have square root. Is it square root of 2? 2. It's not square root of 2, it's 2. 2, and we calculate the main current, which is square root of 2 squared plus 5.333 squared, and the module is 596, and the argument is 20, because the arctangent phi, this angle, is arctangent of 2 over 5.333, and we can say it's 20.556 degrees. From here we can write the main current, which is I, instantaneous. It's 5.696 square root of 2 sine omega t, which is omega 1 t, plus 20.556 degrees. And we can calculate the power dissipated here in this resistors. In this resistance, it's R1 times 5.696 squared, and this is about, this is 100, 5.696 squared times 100, and this is 3244.444 watts. Okay, we did it for when the frequencies are equal And now we are going to do it when the frequencies are different. It means that the current generator operates at 5000 over 2 pi, but the voltage generator works 1 is equal to 5000 times 2, which means 10,000 radian per second. So it means the current wouldn't change here. This part, which we calculated here, this one won't change. This one won't change because its frequency hasn't changed, but here the frequency has changed. So it means that we have calculated again these reactances. Here we have 200 twice, and here we have half of it. Okay, but the resistances stay the same. So we can now calculate this I prime. I prime is, let's calculate it. Okay. We can say that here we have an impedance of R1 plus R4 squared plus 200 minus 50 squared. So square root, let's say this is xl1 minus xc1 squared. So it means we have z is equal to 300 squared plus 150 squared. That will give us an impedance of 335.41 ohms, and from here we can calculate E prime is equal to V1 over Z. V1 is equal to 600 over 335.41 and is equal to 1.788 amps. And we can calculate as well the impedance. Remember, the impedance is complex. We have the module, and the argument is, because it's inductive, it's plus 26 arctangent of 150 over 300. It's 26.565. Okay, and now we can calculate the complex. The current will be I in complex will be 1.788. Okay, remember that we have voltage P over 2, so P over 2 here minus 26.56, and it's 1.788, and the argument is 63.44. So this is prime. Okay, I write it down somewhere. Let's take this one. Take another board. So let's write first I prime. 2 prime is same square root of 2 sine omega 2 now, omega 2t. This is stays the same, and I prime is equal to 1.788 square root of 2 sine omega t. This is omega 1t plus 63.44 degrees. Okay, so the main current will be I is equal to 1.788 square root of 2 sine, I hope I will have time to finish it, omega 1t plus 63.44 degrees plus I2 prime 5333 square root of 2 sine omega 2t. Now we can calculate the power. It's equal to 1788 squared plus 5.333 squared times R1, which is equal to 100. So the power will be before it was 444 times 4, and now it will be 5.333 squared times 100. This is 2,8444.08, and here 1788 squared times 100, it's 319.7, and the total power will be plus 284408. It will be 3,164 watts. And that's it. Thank you very much.